So we're going to be doing derivatives of transcendental functions. For homework, you are going to have four problems to do. You'll have D, F, K, and N. But in this video, I'm going to go over A, E, H, and J, so you have additional samples to see. So here we go. A. 3A says y is equal to sine of 3x plus cosine of 2x. Now, I'm going to do this one in two ways, but probably for the rest of them, I'm going to do it just one way. So we talked about doing separate statements. So here I have two things that are close to the rule but not actually the rules. So I'm going to turn them into the rules. I'm going to make u equal to 3x and w equal to 2x. So here we go. What can I do with that then? Y is equal to sine of u plus cosine of w now. All right, so what can I do there? Well, I can now take the derivative with respect to x of this statement. So dy dx is equal to d sine u dx plus d cosine w dx. Now that's a problem because I can't take the derivative of u with respect to x or w with respect to x, so I have to use the chain rule. So here we go. I'm going to do d sine u du times du dx plus d cosine w dw times dw dx. Now I can do this side work up here. So du dx is equal to 3, dw dx is equal to 2. And then here we go. Derivative of sine with respect to the right thing is cosine, so that's cosine of u. And then this is equal to 3 plus derivative of cosine w with respect to w is negative sine w, and then 2. And then we have our final answer of 3 cosine of 3x minus 2 sine of 2x. And there we go. All right, the other way we can do that just from a notational standpoint is when we take our derivative dy dx, we're going to have d sine of 3x, and then we can do that with respect to 3x, and then have d 3x with respect to x, right? Plus d cosine 2x with respect to 2x, and then d 2x with respect to x. The important thing here, folks, is that in each case, we have an explicit statement of the chain rule. So here, the derivative of 3x with respect to 3x, or derivative of sine of 3x with respect to 3x is cosine of 3x. Here we have a 3, and the derivative of cosine of 2x with respect to 2x is negative sine of 2x, and then 2, and then we're done, right? So breaking up into steps might be helpful just for some people when we're new to derivatives, and then doing it internally if we feel a bit more comfortable with this sort of weird notation. Your choice. But either way, we get to the same result. So next, let's look at E. 3E says y is equal to x squared sine x. All right, so we do d dx. And the first thing I notice here is, oh God, I have a product rule. First times derivative of second plus second times derivative of first. Oh, that's not that bad at all. So I've got x squared. This becomes cosine of x plus sine of x times 2x. If I want to neaten that up, I can, but I choose not to because I'm done with derivatives. I'm done with the problem. All right, now moving on to 3h. I've got y is equal to x squared cosine of x squared minus 1. Looks like I've got another product, but I've also got something that's not a rule, so I'm going to have to combine some notations here, or some problems here. So the first thing I'm going to do is the product rule. So cosine of, or rather, x squared times the derivative with respect to x of cosine of x squared minus 1. This is the thing I'm going to have to do the chain rule on, plus cosine of x squared minus 1 times the derivative with respect to x of x squared. All right, so now we're going to do some work here to do this in terms of chain rule. So once again, I could do a let statement and turn this into u, or I can just do the funkier notation. I'm going to, let's see, what do? I'll do a let statement just to make notation look prettier there. U is equal to x squared minus 1. So here we go. That turns into du, d cosine u du times du dx plus, and this is cosine of x squared minus 1, and then this is just 2x. So I'm going to come up here and do d dx of this. So du dx is equal to d dx of x squared plus d dx of negative 1. I probably should have left more room here. I am squishing exactly what I tell y'all not to do, but there it is. It's 2x. So I can come back in here and do x squared. Derivative of cosine of u with respect to u is negative sine of u, and then I can take my work from up there. 2x plops in there, plus, I don't like that in the beginning, so I'm just going to move that to the front, cosine of x squared minus 1. And then one last statement just to pull it all together, negative sine of x squared minus 1, boom, boom, 2x. And obviously I could factor out a whole bunch of things and pretty this up if I had to do more work with it, but I choose not to. All right, now I'll just show this the other way. If I was going to do this the other way, this step would be x squared d cosine of x squared minus 1 all over d x squared minus 1, and then I would have, I'd probably put d x squared minus 1 over dx, and then plus whatever this term would be. And then I'd probably want to have a brackets here, because in the next step down, I would have to do d dx of x squared plus d dx of minus 1. And this would just be about grouping and keeping everything in order, but that's the way that would look. So that's h. And then we have j. Okay, so 3j is equal to e to the tangent of x. Nice easy problem here. And so that doesn't look like one of our rules. So here we go, d dx of that. So dy dx is equal to d e to the tangent of x, and I'll do it this way with respect to tangent of x, and then the derivative of tangent of x with respect to x. All right, and so here, this is just the rule, so that's e to the tangent of x, because the derivative of e to the blah with respect to blah is always e to the blah. Okay, and the derivative of tangent x, I know from my rules, that is just secant squared x, and then I'm done. Okay, why don't I do just like one bonus one here, so we can see another one with that had the multiple nesting relationships. Also, I didn't do one with natural log, so why don't I do that? So let's say y is equal to the natural log of cosecant of x to the 5th or something like that. All right, cool. So here we go. I'm going to take the derivative of this, d dx, and that's going to equal dy dx is equal to d ln of cosecant of x to the 5th. That's the thing. That's weird. Over the derivative of cosecant x to the 5th. And the next thing here is d cosecant x to the 5th, right? And then I want to do this with respect to x to the 5th because I have a rule for cosecant of something. So with respect to something, that works. And then d x to the 5th with respect to x. That's what I need to get to. So we know that if it's natural log of something, that the derivative of that is just 1 over the something. So I get 1 over cosecant of x to the 5th. That's the first term. Cosecant of something, that becomes negative cosecant of the same thing, cotangent of the same thing, and then I've got x to the fifth, so that's just 5x. Oh, actually I will simplify this one because it comes out kind of pretty. Boom, boom. This is just apparently negative 5x cotangent of x to the fifth, right? But I needed to do 3 replacements. If I was doing this with let statements, I would have let u is equal to cosecant of x to the fifth, then this would turn into y equals ln of u, and then I would probably do w is equal to x to the fifth, this would become cosecant of w, and then I have 3 things whose rules I know. So there you go. Hopefully this helps you with your homework, and yeah.